Welcome to Homework Lib.
So over here we want to generate the possible structural isomers of the molecular formula c5h10. In this case, I'm relying on the translation from Google Translate of your question, so hopefully that is correct. So the first thing that we need to get is the degree of unsaturation, or in which we're going to see that we're going to have one unsaturation, which corresponds to either one double bond or one ring in our structure. So let's start with the ring structure that can be generated. In this case, it would be cyclopentane. Oops. Which, as you can see, has a CH2 on each of the vertices of the pentagon, accounting to C5H10. The other ones are going to be different versions in which I'm going to have a double bond. So all of the possible configurations in which a double bond is going to be present. So let's go through all of them. The first one would be on the first position, 1, 2, 3, 4, 5 carbons. The next one would be a double bond here, 1, 2, 3, oops, 4 and 5 carbons. Now we can have configurations, the other two being a double bond on this position or in these positions are going to be symmetrical to the first ones that we have already written, so they are the same. So we have all of the possible structures with 5 carbon atoms on the main chain. So we're going to go now with the configurations with 4 carbon atoms on the main chain. So we're going to have 1, 2, 3, and 4 carbon atoms, and we're going to be missing one. So we can have it on this position, for example, and we can have the double bond right here. I'm going to write down the same structure as before, and the double bond cannot be on this position because it would be the same compound, just like switch it up a little bit, right? So now the double bond, I'm going to write it down over here. The other 4 carbon atom on the main chain and one on the substitution configuration is going to be this one. So those are all of the possible structural isomers with 4 carbon atoms on the main chain. Now let's go with the configurations with 3 carbon atoms on the main chain. 1, 2, 3, and that means that we need to have 2 on the other side. And guess what? As you can realize quite quickly, what we're going to see is that we're going to be repeating the same structures that we have here. So we have finished our problem, and these are all of the possible configurations that we can generate. So that would be all. And just for enumeration purposes, the first one would be cyclopentane. Second one and third one, it would be pent 1 in, pent 2 in. Here we're going to have the configurations 4, 5, and 6. So that would be all. Thank you very much and have a good one.